Think you know motorcycle engines? Well, here's a puzzle for you. Why would Honda pour years and millions into designing oval pistons, an engineering marvel with 8 valves per cylinder? Imagine these pistons as the engine's secret weapon, a bold experiment aimed at redefining performance. Intrigued? You're not alone. This groundbreaking design wasn't just ambitious, it pushed the limits of what was possible in motorcycling. But here's the twist. Not everything went according to plan. Stick around as we dive into the story behind this fascinating innovation, uncovering the genius, the challenges, and the lessons learned from one of engineering's boldest pursuits. In the late 1970s and early 1980s, motorcycle racing was a battlefield of engineering, performance, and innovation. If you wanted to win, you needed speed, and for most manufacturers, two-stroke engines were the weapon of choice. These engines were compact, lightweight, and produced immense power for their size. But they came with significant downsides. They were noisy, inefficient, and heavily polluting. For Honda, a company built on precision engineering and innovation, two-stroke engines didn't align with their core values. So they set out to change the game entirely. Honda was steadfast in its commitment to four-stroke engines, believing that they were cleaner, more reliable, and capable of surpassing two-strokes with the right advancements. However, racing wasn't won on theory. Lap times told the story. Four-stroke engines faced a fundamental disadvantage in power-to-weight ratio, where two-strokes excelled. This dominance made two-strokes the engine of choice on racetracks worldwide. For Honda, sticking with four-stroke engines wasn't just a technical challenge. It was a high-stakes gamble that put their very reputation for engineering brilliance on the line. By the late 70s, Honda's pride was at risk. Racing wasn't merely about trophies. It was a stage to showcase engineering supremacy. Losing to two-stroke rivals threatened Honda's image as an innovator. They just couldn't afford to fall behind. During this time, one pivotal race highlighted the problem. Honda's four-stroke machines lagged behind, unable to match the raw speed of two-stroke competitors. This glaring gap in performance pushed Honda's engineers to find a solution, sparking the genesis of the NR project. Honda's engineers faced what seemed like an insurmountable challenge, building a four-stroke engine that could outperform the lighter, more powerful two-strokes. This wasn't just a technical hurdle, it was an existential crisis. To tackle it, Honda launched the NR750 project, a race bike that embraced radical design choices. The early NR750 featured innovations like monocoque frames and 16-inch wheels, but its most groundbreaking feature was hidden inside the engine: oval pistons. The idea was bold, yet logical. If two-stroke engines had an advantage by delivering twice as many power strokes per cycle, why not design a four-stroke engine that mimicked the airflow and power delivery of a V8 while maintaining the compact size of a four-cylinder? Oval pistons with multiple valves offer the potential for this level of efficiency. On paper, the concept was brilliant. In practice, it presented an array of engineering challenges. Early attempts at implementing the oval piston design were fraught with difficulties. The NR750 prototypes struggled on the track, failing to keep pace with their two-stroke rivals. The bikes were heavy, overly complex, and didn't generate the power Honda needed to win. Despite these setbacks, Honda refused to abandon the project. Instead, they doubled down, determined to push the boundaries of engineering even further. By the early 1980s, Honda's engineers reimagined nearly every component of the engine, from piston rings to connecting rods, to make the oval piston design functional. It was an enormous challenge, but it aligned perfectly with Honda's ethos: relentless innovation in pursuit of excellence. The culmination of these efforts wasn't just a race bike, but a production motorcycle that would redefine expectations. The ideas developed for the NR750 laid the foundation for the NR750, a machine designed not for racing, but for the open road. The NR750 carried forward Honda's legacy of radical innovation, born from their racing frustrations. It was a bold move, but Honda knew success would cement their reputation as engineering pioneers. Before diving into the NR750, let's revisit the revolutionary concept behind oval pistons. Now, on paper, they seemed like the perfect answer to Honda's racing woes, but building them was a monumental task. This was uncharted territory, requiring entirely new techniques and technologies. So, why go to such lengths? What could oval pistons achieve that traditional round ones couldn't? And most importantly, how did Honda turn this ambitious idea into reality? The stakes were clear. Honda wasn't just chasing racing victories. They were redefining what a motorcycle engine could be. Their reputation, their commitment to four-stroke technology, and their innovative spirit all hinged on solving this puzzle. Now, what came next wasn't just a solution, but a groundbreaking design that stunned the motorcycle world. So what was the secret behind Honda's legendary oval pistons, and why were they such a big deal? Let's break it down and find out. What if you could fit the power and breathing efficiency of a V8 engine into the more compact form of a V4? Well, that's exactly the question Honda set out to answer with their revolutionary oval piston design. The idea was radical. Oval pistons could theoretically achieve a significant increase in airflow and power without stepping outside the limits of a four-cylinder engine. But achieving this goal meant rewriting the rules of engine design entirely. The core advantage of an oval piston lies in its shape. A traditional round piston limits the valve area that can fit into its cylinder head. Now, by contrast, the elongated design of an oval piston allowed engineers to double the number of valves per cylinder. Instead of the conventional 4 valves, 2 intake and 2 exhaust, each cylinder could accommodate 8 valves, 4 intake and 4 exhaust. Imagine an elongated room with more doors. The increased number of openings allows for higher airflow and faster gas exchange. For high-performance engines, this efficient airflow directly translates to more power at higher RPMs. However, creating an oval piston wasn't as simple as stretching a circle into an oval. The unique shape posed engineering challenges that had never been solved before. Traditional pistons operate within circular bores, where sealing the combustion chamber with piston rings is relatively straightforward. An oval piston required elliptical rings that could maintain a perfect seal along both the straight edges and the curved ends of the bore. Honda developed segmented rings made from advanced materials to meet this challenge. Additionally, the piston skirts were coated with low-friction materials to reduce wear caused by the increased surface area and unconventional contact points. Each oval piston also required a completely different mechanical setup. Due to its elongated shape, every piston needed 2 connecting rods instead of 1, with each rod attached to opposite ends of the oval. These rods connected to separate crank pins on the crankshaft, mimicking the action of 2 smaller pistons working together. This configuration demanded an offset crankshaft design capable of handling the increased forces generated. Essentially, each oval piston functioned like 2 smaller cylinders sharing a single combustion chamber. When combined with the 8-valve per cylinder design, the engine could achieve the airflow and efficiency of a V8 layout while retaining the compactness of a V4. This unique architecture extended to the valve actuation system as well. Managing 8 valves per cylinder required a dual overhead camshaft or DOHC system with 4 camshafts, 2 for each bank of cylinders. Each camshaft was precision machined to drive the valves using forked rocker arms that controlled 2 valves simultaneously. The tolerances for these components were razor thin, as even minor inaccuracies in valve timing could compromise performance, particularly at the engine's blistering RPMs. To ensure consistent timing, Honda employed a gear-driven camshaft system. This choice, while more reliable and precise than traditional chain-driven setups, carried some significant engineering risks. A single miscalculation in the gear system could have catastrophic consequences, underscoring the high stakes of Honda's innovative approach. The results of these innovations were extraordinary. The NR750's engine could rev to an astonishing 15,000 RPM and deliver 125 horsepower from its compact 750cc displacement. For the early 1990s, these numbers were groundbreaking and showcased the potential of the oval piston. However, this technical brilliance came at a cost. The complexity of the design made it incredibly difficult to mass-produce and maintain. Manufacturing the engine required groundbreaking techniques. Machining elliptical piston rings and honing oval cylinders to exact tolerances were monumental challenges. Cylinder heads capable of housing 8 valves per cylinder were equally difficult to produce. Furthermore, assembling the dual-rod crankshaft and camshaft systems demanded extensive training for technicians. These factors drove production costs to astronomical levels. Despite these hurdles, the NR750 proved that the concept of an oval piston engine was more than just a theoretical exercise. Honda not only built a working engine, but also pushed it into limited production. It was a showcase of engineering ingenuity, a testament to Honda's relentless pursuit of innovation. Now, while the complexity and costs made it impractical for mainstream production, the NR750 left a lasting legacy. It demonstrated that mimicking the breathing efficiency of a V8 within a V4 layout wasn't a pipe dream. it was indeed achievable. Ultimately, the story of the Oval-Piston is one of triumph and limitation. Honda's engineers pushed the boundaries of what was possible, but the inherent complexity meant it would remain a marvel of engineering rather than a practical solution. The NR750 stands as a symbol of Honda's ambition, setting benchmarks for innovation and inspiring enthusiasts to this day. Imagine spending billions of dollars to produce a motorcycle engine so complex it rivaled the manufacturing demands of luxury cars or even aerospace components. That's the story of Honda's NR750. At its core was an engineering marvel, the Oval-Piston V4 engine. While the concept was groundbreaking, turning it into reality pushed the boundaries of 1990s production technology and came with a jaw-dropping investment. The challenge began with machining the oval pistons. Unlike traditional circular pistons, the NR750's elliptical design demanded a level of precision that bordered on obsessive. Honda relied on cutting-edge 5-axis CNC machines, capable of tolerances measured in microns, thinner than a human hair. On the manufacturing floor, every step felt like a battlefield of microns, where even the slightest deviation could spell disaster. Each piston had to fit perfectly into its uniquely shaped bore, and the cylinder bores themselves required custom honing tools to account for their non-circular shape. This was just the first hurdle. The elliptical piston rings added yet another layer of complexity. These rings were critical for maintaining a perfect seal in the oval combustion chambers, which expanded unevenly under heat. Honda engineered segmented rings from advanced high-tension materials, with each piston requiring 5 rings instead of the usual 3. 2 compression rings trapped combustion gases, 2 oil rings prevented seepage, and a 5th spacer ring reinforced structural integrity under immense pressure. This intricate design worked, but fabricating and integrating these rings was a painstaking process that escalated costs. Assembling the engine presented its own set of challenges. The NR750 featured a dual connecting rod arrangement for each piston, which required flawless alignment to function correctly. Each cylinder head housed 8 valves controlled by a gear-driven dual overhead camshaft system. This design demanded unparalleled precision during assembly, with even minor misalignments potentially leading to catastrophic failure. Skilled technicians needed specialized training to build and maintain these engines, transforming what might have been routine work into an all-day puzzle. To ensure consistency, Honda developed dedicated jigs, inspection equipment, and quality control processes specifically for the NR750. Now, these systems were essential for meeting the engine's exacting standards, but made production painstakingly slow. Each engine took far longer to build than a conventional inline-4 of the same displacement. This meticulous approach meant every NR750 felt more like a handcrafted masterpiece than a mass-produced motorcycle. Now, all of this contributed to the bike's astronomical price tag. When the NR750 debuted in 1992, it sold for $50,000, making it the most expensive production motorcycle of its time. For perspective, a top-tier superbike like the Ducati 888 SP5 cost roughly half as much. Adjusted for inflation, the NR750's price tag today would exceed $100,000. Buyers expected perfection for that kind of money, and Honda delivered. But the expense didn't stop at the purchase price. Maintaining the NR750 was a daunting task. Adjusting valve clearances on the traditional motorcycle might take a few hours. On the NR750, the 32-valve setup turned it into an all-day ordeal. Specialized tools and deep expertise were required, limiting the number of mechanics capable of servicing it. For most riders, the NR750 was less a practical machine and more a collector's dream. Now, despite these hurdles, Honda managed to produce around 300 units of the NR750, a remarkable feat considering the effort and expense involved. Each bike represented a monumental achievement in engineering, a motorcycle that showcased what could be accomplished when cost-cutting wasn't a consideration. However, this approach came at a steep price for Honda. The NR750 was never intended to be a commercial success, but instead served as a statement of engineering ambition. It was a costly reminder of the limits of uncompromising innovation. Production may have been unsustainable, but the NR750 left an indelible mark on motorcycle history. It proved Honda's willingness to take risks and demonstrated that internal combustion technology still had room for groundbreaking ideas. The NR750 wasn't just a motorcycle. It was a declaration of what motorcycles could achieve. But for all of its brilliance, it raised a critical question. Was it worth it? Could this engineering marvel deliver on the road, or would its complexity become its undoing? What followed was a test of whether this extraordinary machine could truly live up to its promise. How can a motorcycle as advanced as the Honda NR750 fail? For all of its groundbreaking engineering, the answer lies in what it couldn't deliver as much as what it achieved. On paper, its specifications were remarkable. 125 horsepower from a 750cc four-stroke engine capable of revving to 15,000 RPM. But these numbers didn't tell the full story. The NR750 faced stiff competition from motorcycles that were simpler, lighter, and more practical to ride, both on the track and on the road. Take Honda's own CBR 900RR Fireblade, for example, which launched shortly after the NR750. The Fireblade was designed with a sharp focus on power-to-weight ratio. At just 185 kilograms, it was nearly 40 kilograms lighter than the NR750 while offering similar horsepower. This weight difference transformed the riding experience. The Fireblade felt nimble and responsive, particularly on corners, where the NR750's heavier frame struggled to match its agility. Meanwhile, Ducati's 888 SP5 posed its own challenges. Though it produced slightly less power, the Ducati compensated with strong mid-range torque and a lighter, more balanced chassis. These bikes showed how traditional engineering could deliver performance and usability in ways the NR750's complexity couldn't. A key issue was how the NR750's Oval-Piston engine delivered its power. While 125 horsepower at 14,000 RPM sounded impressive, the engine's performance was heavily skewed toward higher RPMs. Riders had to keep the engine spinning above 8,000 RPM to access its peak power band. Below that threshold, throttle response was muted due to the high internal friction of its 32-valve, 8-connecting rod layout. The narrow power band made the bike less practical for everyday use. In contrast, competitors like the Fireblade and Ducati offered broader, more accessible power delivery, making them more versatile for a range of riding conditions. Its weight compounded these challenges. At 223 kilograms dry, the NR750 carried significant mass, much of it from its complex engine internals. Components like dual connecting rods per piston and elliptical rings added extra material compared to traditional designs. This weight dulled the bike's responsiveness under hard acceleration or braking, making it feel less dynamic in competitive scenarios. While riders appreciated its stable, planted feel at high speeds, this came at the cost of the sharpness needed for superbike performance. Beyond performance, the NR750 faced steep economic hurdles. Its intricate design made manufacturing prohibitively expensive. Hand-assembled components, custom machining, and specialized materials drove its price to $50,000 in 1992, comparable to luxury sports cars like the Porsche 911. This price tag placed it far out of reach for most riders. A niche audience of collectors and enthusiasts embraced it, but the broader sport bike market, where affordability mattered, largely passed it by. Then there were the maintenance demands. Servicing the NR750 required specialists familiar with its unconventional design, particularly the elliptical piston rings and intricate valve systems. Routine tasks, like adjusting valve clearances, were far more labor-intensive than on traditional bikes. What might take hours on a Fireblade could stretch into a full day on the NR750. For riders seeking high performance without the headaches, simpler alternatives were far more appealing. Despite these challenges, the NR750 left an undeniable legacy. Its engineering brilliance showcased Honda's willingness to challenge convention and redefine what was possible. While the Oval-Piston concept didn't survive in production, it inspired respect and curiosity for pushing the boundaries of engine design. Elements like its gear-driven camshafts and aerodynamic bodywork influenced future Honda motorcycles, from racing programs to modern road bikes. Transitioning from its technical flaws to its cultural impact, the NR750 wasn't meant to compete with mass-market sport bikes like the Fireblade. Instead, it was a bold experiment, a showcase of engineering ambition. Imagine a rider taking it out on the road for the first time, awed by its high-revving engine, but frustrated by its demanding nature. In contrast, a Fireblade offered instant ease, its lighter frame and broader power band making every corner feel effortless. The NR750, though impractical, served a different purpose. It pushed the limits of what internal combustion engines could achieve, leaving an indelible mark on motorcycle history. If nothing else, it stands as a testament to the delicate balance between ambition and practicality, a lesson that continues to shape performance motorcycles today. The Honda NR750 was an experiment in pushing the boundaries of engine design. Its oval pistons with 8 valves per cylinder were a bold attempt to redefine performance. While it didn't spark a revolution, it left a lasting legacy, proving that innovation is about daring to dream big. The NR750 challenges us to ask, what's the next boundary motorcycling will break? Progress often begins with ambition, even if the results don't immediately reshape the world. Revisiting our original question, the NR750 shows that breakthroughs start with imagination, reminding us that the future of motorcycling is only limited by our own vision. If you found this deep dive into the Honda NR750's Oval-Piston V4 informative and appreciated learning about this unique piece of engineering, please give us a thumbs up. It really helps the channel grow. And for more in-depth explorations of motorcycle technology and history, subscribe so you never miss an episode.